The detection came quietly at first, a stream of data flowing back from the James Webb Space Telescope as it tracked the interstellar object designated 3I/Atlas. At first glance, it seemed routine, just another careful observation of a body passing through the solar system on a hyperbolic trajectory destined never to return. But buried in the data was a signal that did not conform to expectations, a flicker of light far too regular, far too precise, and far too luminous in character to be explained by natural reflection or the ordinary scattering of sunlight. What emerged from Webb's instruments was something astonishing, artificial lights glimmering on the surface of this traveler from beyond our system. Before we start, smash the like and subscribe buttons for more updates. For decades, astronomers had theorized about detecting technological activity beyond Earth, but almost all of that speculation centered on the search for radio transmissions or megastructures encircling stars. The idea that a telescope could detect artificial illumination on a smaller body, essentially the equivalent of city lights, had been floated in academic papers, usually treated as an extreme thought experiment rather than a practical objective. Yet, Webb's unprecedented sensitivity made the improbable possible. The instrument suite captured a consistent photometric signature that matched no known natural process. Its wavelength profile bore the unmistakable marks of coherent emission, as if vast arrays of lights had been deployed deliberately across the surface of the interstellar visitor. The object 3I/Atlas was already remarkable before this discovery. It became the third recognized interstellar object to pass through the solar system after the famous Oumuamua and 2I/Borisov. Unlike comets and asteroids bound to the sun, such bodies arrive from the depths of interstellar space, carrying within them clues about the chemical and structural diversity of distant planetary systems. Astronomers were thrilled at the chance to study another such messenger, expecting to refine theories of planetary formation and interstellar dynamics. Yet Webb's findings elevated it to an entirely different category, shifting the focus from planetary science to the possibility of encountering evidence of technology beyond Earth. The patterns of light Webb recorded were not just unusual, they were patterned in ways that defied randomness. The fluctuations displayed periodicity, like the alternating pulse of beacons or the structured distribution of illumination across an inhabited landscape. Instead of diffuse glows produced by volatile ices sublimating, there were crisp emissions aligned in grids spreading across the darkened surface. Analysis of the brightness curves showed correlations with rotation, suggesting that as the object spun, different sectors of lit regions came into view. This was not merely reflective scattering of sunlight. The spectrum suggested energy sources generating illumination independent of solar input. The implications are staggering. For centuries, humanity looked to the skies, wondering if intelligent beings inhabited the stars, and now, through the lens of the Webb telescope, there appeared to be confirmation that technological entities existed, and not in the distant future of detection, but right here, brushing through the solar system in the form of an interstellar traveler. The immediate realization was that lights of this nature implied deliberate engineering, the creation of power grids or directed illumination systems on a solid body that could not sustain them naturally. In short, what Webb observed looked like artificial lighting, the hallmark of civilization. What made the observation all the more gripping was the timing. 3I/Atlas was on a fast outbound trajectory, entering and leaving the neighborhood of the solar system in a span of only months. That meant the window of observation was narrow, and Webb had captured something extraordinary at precisely the right moment. Scientists understood at once that this was a rare and fleeting opportunity. Other observatories were quickly brought to bear, but Webb's infrared sensitivity and resolution gave it the advantage in detecting faint structured emissions that could otherwise vanish in noise. The lights it recorded were in the near-infrared range, a choice of wavelength strikingly similar to those used in human-made lighting for efficiency. That alignment raised questions. Was this a coincidence of physics? Or did energy-conscious civilizations converge on similar solutions? To grapple with this, researchers turned to models of planetary albedo, surface reflection, and the physics of artificial lighting. Nothing in the catalog of natural phenomena could replicate the clean spectral lines and the consistency of the emissions Webb picked up. The most natural explanation, that of reflective patches of ice glistening under sunlight, collapsed under scrutiny, as the brightness of the signals persisted even when the geometry of sunlight made such reflection impossible. Instead, the data spoke of active illumination, as though lamps or power-driven panels had been arrayed across the object's surface. The intellectual shock was profound. Humanity had often speculated about interstellar probes, imagined civilizations seeding the galaxy with emissaries, but here was a body gliding through the solar system, apparently equipped with lights. It suggested intentionality, perhaps even habitation. One of the most striking aspects was the sheer scale implied. For the lights to be detectable across tens of millions of kilometers, they must have been extraordinary in output. Whether that meant small but intensely luminous beacons or vast areas covered in steady illumination was a question left to be resolved. But in either case, the conclusion pointed toward advanced engineering. This observation ignited discussions about the purpose of such illumination. Was it functional lighting for inhabitants on or within the object? Was it navigational? A signaling system to indicate presence? Could it even be a communication attempt directed outward, knowing that any civilization with astronomical capabilities would be able to recognize its artificial character? The possibilities unfolded in layers of speculation, each more challenging than the last. If 3 Ice/Atlas carried artificial lights, it implied an intent that went beyond the passive drifting of cosmic debris. It suggested that this object was in some way guided, managed, or inhabited. For scientists and the broader public alike, the discovery called into question fundamental assumptions about solitude in the cosmos. Until now, the evidence for life beyond Earth was circumstantial, rooted in the chemistry of exoplanets and the extremophiles of Earth's biosphere. But light structured in artificial patterns is a direct technological signature, something that does not arise spontaneously. This was not a biosignature, it was a technosignature, an indication not just of life, but of intelligent life capable of engineering. That leap from speculation to detection altered the framework of humanity's place in the universe. The Webb Telescope had been designed to peer into the earliest epochs of the cosmos, to capture the faintest glow of galaxies forming in the aftermath of the Big Bang. That it should also become the instrument that caught the first potential sign of extraterrestrial technology was an irony not lost on anyone. Its sensitivity, particularly in the infrared, allowed it to perceive what older telescopes could never have seen. The layered filters and unprecedented resolution gave it a capacity that, turned upon 3 Ice/Atlas, revealed a phenomenon so unlikely that it demanded rethinking not only of astronomy, but of humanity's expectations of contact. Attention turned quickly to the object's trajectory and nature. 3 Ice/Atlas was traveling on a hyperbolic orbit, moving too fast to be captured by the sun's gravity. This made it a true interstellar visitor, not a rogue asteroid dislodged from the solar system. That fact carried weight, because it implied the lights did not belong to a derelict local body, but were associated with something originating in another stellar system. In essence, Webb had detected not just artificial lights, but artificial lights on a vessel or construct that had traversed interstellar space to pass by our neighborhood. Such a scenario carried profound implications for the scope and reach of technological civilizations. The more detailed the analyses became, the more convincing the artificial interpretation appeared. Spectral decomposition showed peaks consistent with emission spectra of engineered lighting systems. The absence of natural absorption lines that would be expected from reflected solar light reinforced the conclusion. Moreover, the periodic variation in intensity suggested rotation, as though a surface with illuminated areas was slowly turning, revealing and hiding sections in a rhythm consistent with a rotating body. All of this added up to a compelling case that what Webb recorded was not an illusion or artifact, but a genuine detection of artificial illumination. Scientists debated the scale. If the lights were concentrated in high-powered clusters, they could be akin to massive beacons, perhaps designed for signaling across interstellar distances. Alternatively, if they were more diffuse, spread across the object's surface, they might resemble the distributed pattern of urban lighting on Earth, the glow of a settled surface or the infrastructure of a technological habitat. In either case, the requirement of power generation implied machinery, resource management, and intentional deployment. This was not a passive rock, it was an engineered entity. Beyond the scientific community, the discovery reverberated through philosophy, culture, and even theology. The knowledge that artificial lights were detected on an interstellar object stirred imaginations and unsettled long-held beliefs about uniqueness. It was not the aftermath of such a revelation that mattered in that moment, but the raw realization that technology beyond Earth had been glimpsed directly. No longer was it confined to speculation or statistical probability. Webb's sensors had brought it into the realm of direct observation. What fascinated many was the resemblance of the light patterns to phenomena familiar from Earth orbit. Just as satellites and stations emit glints and controlled lighting detectable from below, so too did three I/Atlas display markers that looked like the work of beings controlling their environment. Some described it as seeing a cosmic lantern drifting through the dark, a flare of intelligence moving silently across the void. It was not communication in words or signals, but communication in presence, the unmistakable mark of technology asserting itself against the backdrop of natural silence. Questions of origin proliferated. From which star system had it come? Was it dispatched deliberately toward the sun? Or was the encounter a chance crossing of paths? Did the lights indicate ongoing function? Or were they relics of past activity? Systems still glowing though the makers were long absent. The detection itself offered no answers, only the certainty that something artificial was there. And in that certainty lay the transformation of perspective, the understanding that humanity was no longer just speculating about others, it was observing the handiwork of others. The rarity of such an event underscored its magnitude. Only a handful of interstellar objects had ever been observed, and of those, this was the first to exhibit techno-signatures. The odds of detection seemed astronomical, yet Webb had caught it. That alone hinted that technological activity might be more widespread than assumed. That interstellar space was not as empty of engineered artifacts as once thought. If 1 out of 3 known interstellar objects displayed artificial lights, the extrapolation invited profound reconsideration of the galaxy's technological landscape. As more telescopes turned their gaze on 3 I/Atlas, corroborating Webb's data, the event became an anchor point for humanity's understanding of extraterrestrial presence. The discovery was not the culmination of contact, not an aftermath filled with responses, but the moment of recognition itself, the realization of not being alone. The lights were a message written in photons, a demonstration that across the gulf of space, others had risen to the challenge of engineering their environment, leaving marks visible to those with eyes sharp enough to see. Even without aftermath, the weight of the event itself was enough to reshape human imagination. To detect artificial lights on an interstellar traveler was to step into a new epoch of awareness, one in which the cosmos was not silent and empty, but populated with traces of intelligence moving among the stars. The Webb Telescope, intended as a window into the earliest universe, had also become a mirror, reflecting back the possibility that humanity was part of a broader community of technological beings. And with that single detection, the long quest to answer the question of whether others existed reached a turning point, forever altering the way the universe was perceived. The most captivating element about the detection of artificial lights on 3 I/Atlas was the manner in which it forced astronomers to reconsider what it meant to observe. For centuries, the practice of astronomy had been rooted in decoding natural processes. The birth of stars, the slow evolution of galaxies, the tumbling journeys of comets and asteroids. Everything was framed in terms of physics, chemistry, and the predictable outcomes of natural law. With the sudden confirmation that a body passing through the solar system displayed illumination too structured to be natural, the observational act itself shifted. Now each photon captured by the telescope's instruments had to be scrutinized, not only as the byproduct of matter and energy, but as a possible artifact of engineering and design. The cosmos ceased to be a purely natural canvas and became, however briefly, a stage where technology beyond Earth had left visible marks. The discipline of techno-signature research had always been a niche within astronomy. There were studies that explored what forms of evidence intelligent activity might leave: narrowband radio emissions, large-scale structures intercepting starlight, heat signatures from advanced power systems. Yet the idea of localized illumination was often relegated to the edges of the conversation. It seemed improbable that technology would be detected through something so familiar as lights in the dark. What Webb saw on 3 I/Atlas suddenly elevated this obscure category of possibility to the forefront. Instead of looking for signs around distant stars, astronomers found themselves dealing with a traveler from interstellar space, bearing a visible glow that was impossible to dismiss as random. The geometry of the detection was striking. As Webb tracked the object, its field of view captured fluctuations synchronized with the object's spin. This synchronization meant that the light sources were anchored to its surface rather than being transient jets or reflective flashes. Such anchoring made them all the more compelling. The energy outputs required for these lights to be visible across the distances separating Webb from the object were immense. Calculations suggested that even modestly efficient lighting systems would need power infrastructures comparable to what human civilizations employed on planetary scales. This raised the possibility that the entity, whatever its origin, had mastery of energy generation beyond the capabilities of Earth at present. Another aspect that drew attention was the spectrum itself. Light emissions carry fingerprints of the technology that generates them. Human lights, whether incandescent, fluorescent, or LED-based, show distinctive spectral profiles. The emissions from 3I/Atlas bore similarities to efficient emission technologies, emphasizing peaks where energy loss was minimized. This was not just a random scatter of wavelengths, but a carefully tuned set of emissions that appeared optimized for endurance. That optimization hinted at intent and resource management, a recognition that no civilization wastes energy in interstellar conditions unless it is purposeful. The detection also carried implications for the age and durability of technology. For lights to be shining on an object crossing interstellar distances, either there was ongoing maintenance and operation by some form of presence, or the systems were constructed with such resilience that they could function autonomously for extended periods. In either case, it implied technological maturity at a scale humanity could barely imagine. Interstellar environments are hostile. Radiation, micrometeoroid impacts, and the deep cold of space degrade materials relentlessly. Yet here was illumination persisting, strong enough to be visible across astronomical distances. That endurance spoke of engineering sophistication far beyond Earth's reach. The event also forced scientists to broaden their conception of interstellar travelers. Prior encounters with Oumuamua and Borisov emphasized the natural side of these visitors. They were rocky or icy, tumbling remnants of other planetary systems. Now, with 3I/Atlas, the paradigm shifted. It was no longer sufficient to classify such objects as debris. The possibility emerged that some interstellar wanderers might be artificial constructs, probes, or vessels equipped for journeys lasting thousands or millions of years. Even if not actively piloted, they might serve as carriers of systems designed to survive and to be seen. One of the most thought-provoking aspects of the discovery lay in the question of purpose. Why would a construct carry illumination systems into the void? On Earth, lights serve multiple functions: safety, communication, navigation, and comfort for inhabitants. In space, illumination could act as a beacon, a signal of presence, or a deliberate marker for any civilization with sufficient observational tools. If the lights were indeed placed to be detected, then Webb's success in capturing them could mean the object's mission included being seen. That idea transformed the detection into not just a scientific revelation, but a form of contact, a silent handshake extended across space in the universal language of visible photons. Another layer of fascination came from considering the object's trajectory. Hyperbolic paths mean non-return. 3I/Atlas would sweep through the solar system once and vanish forever into the dark. This fleeting passage made the detection almost miraculous, as though the cosmos had opened a window for humanity to glance through before closing it again. The brevity of the encounter gave urgency to every observation. Researchers scrambled to capture every possible detail, knowing that once the object departed, it would carry its secrets beyond reach. In this way, the detection resembled a cosmic messenger brushing past, leaving behind only a glimpse of its illumination as evidence of its existence. At a deeper level, the discovery reshaped how scientists considered the distribution of intelligence in the galaxy. For decades, statistical reasoning based on the Drake equation had framed expectations. Civilizations might exist, but they would be rare and distant, their signs faint and hard to detect. Yet here, within the brief span of a few decades, humanity had encountered 3 interstellar objects, and one of them bore unmistakable techno-signatures. The odds seemed suddenly different. If even 1 in 3 such objects revealed artificial lights, then perhaps the galaxy was more filled with technology than had ever been assumed. The rarity of detection no longer looked like a measure of absence, but rather of observational limits, and Webb had pushed those limits far enough to pierce the silence. The philosophical implications were immense. For millennia, humanity had speculated about its uniqueness. Religious, cultural, and scientific traditions all wrestled with the question of whether the stars were populated by others. Now, through the precise gaze of an infrared telescope, a piece of that question had been answered. The knowledge that artificial systems had been detected on an interstellar traveler did not rely on interpretation of ancient texts or on abstract probability. It rested on direct measurement. Humanity had looked outward and found that it was not alone in shaping matter with intelligence. What gave this realization a particular resonance was the universality of light. Photons travel unimpeded across the void, carrying information from their source to the detector. By emitting light, whether intentionally or incidentally, the makers of 3I/Atlas had created a bridge across interstellar distances. Webb's instruments became the receiver of that bridge, converting signals into human understanding. In this sense, the encounter was less about physical proximity and more about connection through shared physics. The same principles that allowed humans to illuminate their cities at night appeared to underlie the emissions detected on the visitor. It was a cosmic rhyme, a reminder that the laws of nature bind civilizations into a common framework, even when separated by light years. For those studying the sociology of discovery, the event highlighted the transformative power of observation. Unlike theoretical arguments or indirect evidence, the act of seeing changes perception instantly. The structured lights on 3I/Atlas were not hypotheses. They were there, recorded, undeniable. This directness collapsed centuries of speculation into a moment of recognition. Every field of human thought, from philosophy to engineering, suddenly had to contend with the reality that intelligent activity beyond Earth had been glimpsed. The technical achievement of the Webb telescope in making this detection cannot be overstated. Its suite of instruments, particularly the near-infrared camera and the mid-infrared instrument, were capable of teasing faint signals from the overwhelming background of cosmic radiation. By isolating the emissions from 3I/Atlas, Webb had proven that the search for techno-signatures could expand far beyond traditional approaches. No longer would the search be confined to listening for radio waves or scanning for megastructures. Now, even modest-sized objects could be evaluated for signs of artificial modification. This broadened the search strategy enormously, suggesting that the galaxy might be littered with small, glowing travelers waiting to be noticed. The event also prompted a re-evaluation of what contact might mean. Traditionally, the idea conjured images of direct communication, perhaps even encounters with spacecraft or beings. But contact in the astronomical sense can occur through observation alone. By detecting artificial lights, humanity had effectively engaged in a form of silent dialogue, one in which the only message was the existence of the lights themselves. Yet that was enough to signal intelligence, enough to convey that across the abyss of space, others had left a mark. Contact, in this view, did not require voices or responses. It required only the recognition of technology. The detection challenged engineers and physicists to imagine what kind of infrastructure could produce and sustain such lights. Were they powered by compact fusion devices, or by harnessing energy from radioactive decay? Did they rely on solar collection? And if so, how did they store energy during the long journey through interstellar night? These questions underscored the technological leap represented by the discovery. Any solution that allowed illumination to persist across the voyage implied mastery of energy systems and materials science far beyond humanity's current frontier. The lights were not just visible phenomena, they were testimonies of capability. The moment of detection also carried a symbolic weight. For the first time, the great question, "Are we alone?" had been touched by empirical evidence leaning toward a negative answer. The cosmic silence that had haunted thinkers for generations was broken. Not by words, but by the glow of artificial light on a wandering traveler. Humanity's role as observer was forever changed. The night sky, once a realm of natural beauty and mystery, now bore traces of companionship. Somewhere out there, intelligence had walked the same path of manipulating energy, creating illumination, and leaving footprints visible to distant eyes. As the world grappled with this revelation, the lights themselves remained steady, unconcerned with the impact of their discovery. 3I/Atlas continued its course, gliding silently through the solar system, its illuminated surfaces turning in slow rhythm, offering fleeting glimpses to the instruments trained upon it. The detection was a reminder that the universe's vastness does not preclude encounters but frames them as rare, precious moments of recognition. Webb had captured one such moment, and in doing so, it had expanded the horizon of human understanding beyond anything previously imagined. From that point onward, astronomy could no longer be practiced with the same assumptions. Every interstellar visitor would be scrutinized for signs of engineering. Every anomalous glint would be weighed for its potential as a techno-signature. The discovery ensured that the search for intelligence beyond Earth was no longer a fringe endeavor, but a central part of astronomical inquiry. In detecting artificial lights on 3I/Atlas, humanity had taken the first clear step into a broader universe where intelligence was not confined to a single world but scattered among the stars, waiting to be noticed. The fact that the James Webb Space Telescope captured structured illumination on 3I/Atlas was not only a revelation about extraterrestrial engineering, it was also a direct test of humanity's observational readiness. For decades, there had been discussions in scientific circles about whether we would even recognize alien technology if we saw it. This event provided an answer. The sophistication of Webb's instruments and the analytical tools available meant that humanity was prepared, at least technically, to recognize techno-signatures when they appeared. The very act of distinguishing artificial illumination from natural reflection proved that the methods of astronomy were capable of more than just studying galaxies and exoplanets. They were capable of identifying intelligence itself. An especially compelling detail was how the light patterns interacted with the object's rotation. As 3I/Atlas spun, certain arrays of light appeared and disappeared in a rhythm too deliberate to be mistaken for random patches. This created a unique opportunity for analysis. By timing the exposures and mapping the intervals, astronomers could essentially reconstruct the distribution of illuminated areas across the surface. It was almost like watching a globe of another world turn beneath faint streetlights. These rotating signals added credibility because they displayed coherence, an attribute not easily explained by natural processes. It was as though the surface had been designed with networks of illumination visible from space, much like the way Earth's city lights appear to orbit with the planet when observed from a distance. Another striking element came from the temporal stability of the emissions. Natural sources of brightness, such as outgassing plumes or reflective facets of crystalline ice, tend to vary unpredictably, their intensities rising and falling depending on solar heating or rotational tumbling. In contrast, the lights on 3I/Atlas maintained a steadiness over extended observation windows. Stability is a defining hallmark of engineering. It implied that the emissions were not a byproduct of random geology or chemistry, but the output of a controlled energy system calibrated to remain consistent. That level of regulation spoke volumes about the intentions behind it. The detection also opened new frontiers in comparative analysis between Earth's techno-signatures and those observed on the interstellar traveler. On Earth, satellites easily detect the glow of cities on the night side of the planet, patterns of energy expenditure that map directly to civilization. When comparing these to the emissions of 3I/Atlas, astronomers noted both similarities and differences. The similarity was in the structured, grid-like arrangement, something that conveyed planning and distribution rather than chaos. The difference was in the spectral range. The emissions skewed toward wavelengths optimized for visibility in the infrared, suggesting a possible adaptation for energy efficiency in colder environments. This adaptation alone hinted at the technological culture behind the lights, one that engineered systems to endure deep space conditions. Contemplating the possible functions of the lights added another layer of fascination. One hypothesis considered the lights as navigational beacons, potentially used by other vessels or constructs passing through space. Another posited that the illumination could serve to regulate internal conditions of the body, perhaps providing warmth or energy for enclosed habitats. There was also speculation that the lights were symbolic, meant as deliberate signals to indicate technological presence. If so, the act of detection would not be incidental but anticipated, the lights functioning as a kind of cosmic lighthouse for civilizations with instruments advanced enough to observe them. The orientation of the illuminated regions provided still more intrigue. They appeared distributed across specific latitudes, rather than spread randomly, which suggested strategic placement. This could indicate that the engineers behind the system optimized coverage, ensuring that no matter how the object rotated, certain portions remained visible to distant watchers. That kind of foresight demonstrated not just engineering, but planning for detection. It raised the tantalizing possibility that 3I/Atlas was intended to be observed, an interstellar calling card sent through the void. Equally fascinating was the question of scale. Was 3I/Atlas itself a vessel, or was it a carrier for something embedded within it? The detection of lights could suggest an inhabited surface, but it might also indicate machinery or enclosed structures beneath protective shells, with only illumination escaping outward. If it was a vessel, then its engineering surpassed even the most ambitious human concepts of starships. If it was a probe, then its lights may have been deliberately modest compared to the true scale of its function, which might be hidden beneath its crust. The ambiguity only deepened the sense of wonder. If you liked this video, please give it a like and subscribe to our channel. Also, leave your comments below and tell us, what are your thoughts on James Webb detecting artificial lights in 3I/Atlas? We want to hear from you. Thank you for watching, and see you next time.